In our demonstration today, we're going to hook it up to our data transfer unit so we can actually talk to the sensor through a laptop. Obviously, if you have your own telemetry system, digital telemetry system 232 or 485, you can do this yourself. But today we're going to use our data transfer unit, which is available on our sales channels. We simply plug the sensor into the USB, into the subcon connector. We then turn on the data transfer unit. This is talking 232 to the USB port of the computer that Kay has, and is also powered through a USB port of the sensor.
Cool. I think you forgot to mention the cable if it's pigtailed.
Oh yes, sorry. So if this is pigtailed, obviously this is a different connection. For those pigtailed customers and want to talk to it for a DTU, we offer a converter kit, which is a DIN connector with a chocolate block on the end, and this easily plugs on the end of the sensor using the chocolate block termination. Again, there's instructions on the website on how to do this.
Perfect. Okay, so now the sensor's connected. I'm going to show you how to communicate with it through our A&B utils. So this is a utility program. It's a terminal that you can download, a terminal program you can download from our website free of charge. And when you open it, you get a landing page like this, which shows all the COM ports on your computer. Which one did you plug me in? 6?
6, yeah.
So I need COM 6, so I'm going to choose port 3. And here it finds the COM port, and it automatically finds the baud rate that the sensor is running at. Then it comes out, once it's found the sensor, it gives you the information on the type of sensor, the serial number, and the firmware versions that it's running. And then it gives you 3 options. So you can install new firmware, download the data from the sensor, or open a command line prompt. So the idea of this is that it's just really easy and intuitive. And if you want to install new firmware, you just select option 1 and then go through the stages. It asks you a series of questions, and you just reply to the questions, and it does automatically upgrade your sensor with new firmware. So it also takes the new firmware straight from our website, so you don't have to worry about downloading it from there anymore. So it really is, hopefully, easy to use. We've had really good feedback on this utils program. But now I'm going to show you option 3, the command line prompt, because we want to access the sensor menus. So when you click on 3, you get the splash screen come up, which gives you more information about the sensor. And as you can see here, the date and time are currently set at 0. So the utils program automatically sets the sensor's date and time to the current date and time of your laptop. So that does it automatically. You just need to wait a minute or 2. So once you've got that, you can type menu to access all the menu functions of the sensor. And here they are. So we have 3 different kind of types of functions. We have system functions, measurement functions, and data functions. And simply by typing the function there that's in capital letters will give you access to the kind of option on the sensor. And then it is hopefully very intuitive to turn on and off things or to change things. You just follow the questions that it asks you. So if we just go through these line by line, if you type version, it gives you that splash screen that you can see at the top already, so we don't need to do that. If you type time, you can change the date and time of the sensor. If you type mode, which we'll do, you can change between controlled and autonomous operational modes. So I'll type mode in there, and you can see it gives you an option. So maybe, Nathan, you can talk a bit more about this?
Yeah, so the difference between these is, one, manually controlled is where you're on a telemetry platform and you can send a scan command so that you can control the sensor in real time. Autonomous mode is where you can set interval and start delays. You can hook the sensor to a battery pack or remote battery system, have a start delay, and it will start monitoring as soon as the time's up and it starts to go. You don't need any end user intervention for this. It does it completely automatically. And that's the 2 key differences between the controlled and autonomous system.
Perfect. Okay. So we have lots of people, lots of customers that use the autonomous mode, don't we?
Yeah.
Okay, so if we'll keep in manual for now and go back to the menu. And we'll carry on going through these. So that was mode, switching between controlled and autonomous. We can go to board, where we can change the baud rate.
Yeah, so this is just all around your data rate speed from the sensor to your device. We go anything from 9600 to 11500. From a factory setting, the baud rate set at 57600, as Kay showed you earlier. When we booted up utils, it found 57600, but this is completely user configurable depending on your own integration system. And we have customers using anything from 9600 up to 11500.
Perfect. So the next function is interface. So this is to change, I'll type it in so you can see, but this is to change between Modbus or keyboard communication. So maybe you can say a bit more about that. There's lots of Modbus
There is.
info, isn't
There's
there?
loads of Modbus info. So there's lots of Modbus info on the website, giving you all the Modbus command protocols for all the terminal protocols that we have. It's completely configurable. We've integrated it into a number of 485 Modbus telemetry platforms now. I would say this is a really big improvement we've made during the course of 2024, working with telemetry platform integrators and updating their Modbus protocols. So it's really easy to integrate now.
Perfect. I'll keep on terminal mode. One thing to say is that if you are in Modbus mode, when you open utils, it automatically switches out, doesn't it?
Yeah, so obviously there is a way that you can return to telemetry through from a Modbus system by sending a #702 command to the sensor. Utils does that automatically when you turn it on and sends a #702 and takes it out of Modbus mode. So you can then come back to the terminal mode interface.
You can also change the Modbus address from that function there, and
Yeah.
the underscore address if you want to.
Yeah, so all the sensors are currently have a Modbus address of either 55 if you already have one, or there'll be the last 2 digits of the serial number. Obviously, if there's a conflict with pre-existing sensors on your Modbus system, this can be easily changed using the Modbus underscore address protocol.
Yeah, so actually that reminds me about the serial number. You can find the serial number on the splash screen by typing version, but it is actually now on the sensors.
It is displayed on the sensor on a label, which you probably can't see on that resolution, but they all carry the labeling now on the sensor.
Perfect. Okay, so if we're going to move on to measurement functions now, and the first one is immersion, so I'll just type that in to show you. But basically, all the sensors now have an immersion sensor on. So the sensor won't start scanning until the front surface of the transducer is immersed, which is really good, really handy for when you first have it and you want to kind of check the comms on the lab bench. You can disable the immersion sensor and check the comms, otherwise it just keeps beeping at you. But yes, also got other uses.
Yeah. So we've got customers now that are using this to test not only to sensor deploy, but the whole telemetry platform and a multi-parameter system, where they drop the sensor in. Is it immersed? Do they turn on the whole telemetry platform to start doing the multi-parameter measurement, or do they just wait until it becomes immersed? So this is a really good way of just checking that, not just the sensor, but other systems and sensors that you might be deploying as well, just to save power. It's done immediately when you send a scan command or when it starts measuring, and it does it straight away, and it will shut itself down if it's not immersed, and then repeat that check at a preset level.
What about that riverbed customer?
Yeah, so we've had people who have deployed it in sort of estuarine environments where they're looking at dry wet monitoring. So of course the tide goes out and comes in, so it stopped monitoring when the tide goes out, and then come back in when the tide comes back in, it start monitoring again, saving power for remote platform deployments.
And kind of storm drain applications and this type of things, isn't it?
Yeah.
So I'll keep that on for now, but that's the immersion sensor. Interval is the next one, and that's so you can set a time delay between the measurements. If we check on this now, if I can spell it right, if you leave it at 000, that's continuous monitoring, and then you can go from between 15 minutes to 240-minute intervals. So we'll put it on continuous, but I don't know if you can.
No, so when it goes to sleep for the wait time, the sensor goes to sleep, so it goes into its lower power mode. So that's just around saving battery.
Yeah, we've had lots of discussions with customers about saving battery in low power mode, haven't we?
Yeah.
This is kind of future plans.
Yes.
But we're doing all we can to lower the power.
Yeah.
So next, after interval, we've got the scan functions. So we've got, at the moment, we've got a scan O and a scan F. which is a salinity cutoff. So scan O is a high salinity, scan F is a lower salinity. And we've also got, as you can see, an O1 and an F1. So that's if you want to do just get a single result back and then turn the sensor off. Again, this is the low power application, isn't it?
And we've got customers now that have written terminal programs where they send a scan O, turn the sensor on, send a scan O1 command, wait for the pH to be returned. Once the pH returned, they just shut down the sensor, so it saves power on their whole measurement system.
Okay. So yes, if I type scanO now, the sensor will just start scanning, and I won't do that because it's just on the bench. But the other two sensors we've got in tanks are scanning now. So the last measurement functions are stop and shut down, which really just speak for themselves. And then we have the data function, which is type in results, which I can do now. You'll see it gives you a list of all the files. So each sensor contains an SD card inside, which saves all the data in CSV format, which you can access from either here from the menu, or if you remember from the beginning, when you open utils, one of the options is to find the results and download the data, so you can get it from there too. But hopefully you can see it's really straightforward to use, really intuitive. If you need more information or want to get in touch, please do so. We'd be happy to hear from you.